Morning students, microprocessor start universal synchronous asynchronous receiver transmitter. What is called the SAR? Universal synchronous asynchronous receiver transmitter. It is an integrated circuit A251A. The A251A is a programmable chip designed for the synchronous and asynchronous serial data communication packed in a 28-pin DIP. The 8251A is enhanced version of the 8251. It acts as a mediator between the microprocessor and peripheral units. It converts serial data to parallel form and vice versa. So this is the pin D type. Let me see later. Okay. So this is the architecture. It includes 5 sections: read-write control logic, then transmitter, so the transmitter, then receiver, data bus buffer, and modem control. Okay, so 5 units: read-write control logic, transmitter, receiver, data bus buffer, and modem control. The first one is here: read-write control logic and registers. The chip select. When this signal goes low, the 8251A is selected by the MPU for communication. So this is usually connected to decode a address bus. Then write logic. When this signal goes low, the MPU either writes in the control register or send output to the data bus buffer. So this is connected to IO write or memory write. Then read. This signal goes low, the MPU either reads a status from the status register or it accepts the data from the data buffer. So this is connected to either IO read or memory read. Then clock. This is the clock input usually connected to the system clock. This clock does not control either the transmission or the reception rate. The clock is necessary for communication with the microprocessor. Then control register. This is a 16-bit register for control board, consists of 2 independent bytes. The first byte is called the modem instruction and the second byte is called the command instruction. These registers can be accessed as an input port when the C D bar pin is high. Then status register. This input register checks the ready state for a peripheral. The register is addressed as an input port when C D bar pin is high. It has the same port address as the control register. Then data buffer. This is a bidirectional register, can be addressed as an input port and an output port when the C D bar pin is low. Then we come to transmitter section. The transmitter accepts parallel data from the MPU and convert them into serial data. It has two registers, a buffer register to hold 8-bit and an output register to convert 8-bit into stream of serial bits. TXD, that is transmit data. The serial bits are transmitted on this line. Then TXC bar, transmitter clock. This input signal controls the rate at which bits are transmitted by the USART. The clock frequency can be 1, 16 or 64 times the bud. When the chip select is 0, it activates. Okay. That is, this signal is high, then read signal is high, and the write signal is low, then MPU writes instruction in the control register. Okay. When this is low, then see D bar is high and read signal is low and the write signal is high, then MPU reads status from the status register. Then for this signal is low, that is C D bar is low, then read is high and write is low, then MPU output data to the data buffer. Then when C D bar is low and read is low and write is high, then MPU accept data from the data buffer. Okay. If CS bar is high, whatever may be the input, then USART is not selected. The next one is a receiver buffer. In the transmitter, already I have explained TXE. Now, ready, TX ready. This is an output signal. When it is high, it indicates that buffer register is empty and the USART is ready to accept the byte. It can be used either to interrupt the MPU or indicate the status. This signal is reset when the data byte is loaded into buffer. Then empty, TXE or TXMT. This is an output signal. Logic 1 on this line indicates that the output register is empty. This signal is reset when the byte is transferred from the buffer to the output register. Then receiver section. The receiver accepts serial data on RxD lines from the peripheral and convert them into parallel data. Receive data, RxD, receive data. So bits are received serially on this line and convert into parallel byte in the receiver input register. Then RxC, receiver clock. This clock signal that controls the rate at which the bits are received by the USART. In the asynchronous mode, the clocks can be 1, 16 or 64 times the bud. Then ready, receiver ready. This is a output signal. It goes high when the USART has a character in the buffer register and is ready to transfer it to the microprocessor unit. This line can be used either to indicate the status or to interrupt the MPU. This is the pinout diagram of 8251A. So various pins are attached. The detail of the pins. So D0 to D7 is a parallel data. Then C, D bar is a control register or data buffer select. Then read control, write WR is a write control. Then CS is a chip select. Then clock, CLK is a clock, that is at 12. Then reset. So pin number 13 is a reset. Then transmitter clock TXC. And then TXT is a transmitter data. Then RX is a receiver clock. Then RXD is a so the pin details are given here.